Alrighty. We are now live streaming, so welcome to everybody on YouTube or otherwise. For those of you who are joining on Zoom, just a reminder to change the little bar where you can talk to people from saying host and panelists to saying everyone. If you'd like to talk to everyone, if you want to just talk to the three of us, you're welcome to do that too. Welcome to everybody. Let us know where you're from. It is RASC tradition to let us know where you're joining from, and also generally speaking what the weather is there, in case, hi Lisa, in case it's you're getting good views and everyone else is not. So today we're going to be talking about the upcoming year. It's 2022 is right around the corner, and that means that it's time to look at all of the awesome things that are going to be happening. For me, it's the time of year when I go through my observer's handbook and write down all of the cool stuff. Chris is here to help with that because Chris has already done this for multiple different outlets, including Sky News.
Just came today.
Oh my goodness, yay, okay, good. I will be honest, and I know that we've been dealing with a lot of these problems, and so a heads up to those of you who are members, we are dealing with problems with our shipping house. Everyone's favorite thing. Guaranteed, I'm sure you're all miserable not getting your observer's handbooks. Don't worry, we're all miserable too. They are on their way now though. They are on their way out the door. Many of the orders have already been sent. And so don't worry, your observer's handbooks are coming, and you'll be able to get to planning your next year. But even if they're not there, Chris is here to, yay, a few people are getting this, good stuff. Chris is here to help us with what to look at this year.
I was going to cheat and use the Jan-Feb Sky News to figure out what was coming in the new year, because they always have an article, but mine hasn't come yet. So and I didn't feel right twisting Alendria's arm, so I did my own.
That's fair. I don't have the list either, but Sky News does have a list of the 10 best things to see this year.
Yeah. Welcome.
You may also recognize or not recognize another person that's here today. Samantha's here. Samantha is the outreach assistant at RASC. She and I work together very closely on a lot of stuff. And so she'll be joining for the session today.
Yeah, it's kind of Insider's Guide meets Explore the Moon. We need what's a shipping name for that? I don't know. Yeah. Insider's Moon.
Insider's Moon. Yes, so for those of you who don't recognize Samantha, Samantha hosted a live observing program show with us earlier this year, and also did a lot of the back work on that. So starting off today, I think we're going to talk about something that a lot of astronomers are excited about.
Yeah, Comet Leonard. So when Jenna and I laid out the schedule for what we were going to cover we didn't know that there was going to be a cool Comet Leonard in the skies for us to all look at. So we decided we better devote some time today to that. Here it is, this last end of the year little gift to us. So what I'll do is I'm going to show my screen and give you some basics. So let me do this first and move little heads out of the way. And so what I've got here is I'm sharing a top-down view of the inner solar system centered on the sun as of December 12th. And the reason I've put December 12th in is because that's the day on which Comet Leonard will be at perigee, or closest approach to Earth. So essentially what's happening is that the comet was discovered back in January, and the comet's designation, C/2021 A1 Leonard, refers to the fact that it was the first comet discovered in the first fortnight of 2021. So we take the year, we divide it into 26 blocks of 2 weeks, and then we assign a letter code to each of those 2-week blocks. And the first 2 weeks of the year is A, so a discovery on around January 3rd of 2021 becomes C/2021 A1. And then Leonard is the person that discovered it. So it was, I think, G.J. Leonard down at the Mount Lemmon Observatory in near Tucson, Arizona, discovered it. And it was way out in the outer reaches of the solar system when it was discovered, probably with a on a photographic image, something that was moving in the sky. And once you get enough images of it, you can determine its orbit, then you can tell what it's going to be doing. And the orbit predicted that it would reach perigee in December here, and then perihelion, close passage to the sun, in the first week of January. So what I've got here is the 3D model of the inner solar system, and the comet Leonard's orbit is the light blue line. So you can see it's sort of this long hyperbolic orbit that comes in. And of course, comets enter the solar system from all different directions because they're originating out of the Oort cloud, which is that spherical shell of comet-like bodies or icy bodies that extend way beyond the Kuiper belt in the outer reaches. And so they can come in at any angle. And this one is coming in sort of at a high inclination, coming down. And at this point, then on Sunday morning, it's going to reach its perigee. So that this little tick that you can see, this little tick mark on the orbital line, that's its perihelion point. But the geometry I'm showing you here right now is the morning of December 12th, Sunday morning, when it'll be closest to the Earth. And so the comet's going to pass Earth on its way to the sun. It'll get bigger and brighter, theoretically, as it looms larger, as it's nearer to Earth. But because it moves rather rapidly, that passage will happen over a day or two, and then it'll start receding. And what'll happen is that every morning it'll get closer to the sun in our sky, and I'll bring up a sky view here in a second. Then it's going to disappear for about a day as it passes the sun, and then enter the evening sky, but it will not climb very high in the evening. So you really want to use this week as your chance to see it. So I'll go through kind of some of the objects in the sky that it'll fly past to guide you to seeing it in the morning sky over the next few days. So yeah, that's how it works. And then once it hits perihelion, and that perihelion, by the way, is, you can see it's quite far from the sun. So I don't think it's at much risk of breaking up. Comet Ison a few years ago I think, had a much perihelion much nearer to the sun. And so it basically fell apart once it rounded the sun. But this one I think should stay put, but it won't come back. So the comets that have the designation C are non-periodic comets that effectively don't come back, or if it ever does, it'll be tens of thousands or hundreds of thousands of years from now. A comet that's a P/ something is a periodic comet. So we number those and add them to a list. So Halley's Comet is P1, the first one discovered. And by now we're up to, I think, P in the 400s that we add. And we discover them every month, another P comet. So, and those are the ones that we actually know that are coming back, so that we can actually get a sense of what to look out for in the next, next year. We can say that, Comet 67P, Churyumov-Gerasimenko will be good into such a month because it's periodic and we know where it's going to be.
There's a question from the chat from Peter, which is, what speed is the comet traveling at? Do we know that?
I don't know whether this reports the speed. Let me just see if it does.
It seems, sorry, and I definitely like layperson's description, seems like it's going fast, because like it seems to be moving a lot each night. Yeah,
it covers it covers about a fist and a half, or about 14 degrees in a week. It's about several finger widths of the sky in a night. Everything traveling through the solar system is at a high rate of speed. I don't happen to know the velocity, but somebody can look it up, do a Google search and share it with us when they look it up. All right, so let me put this away and go over to Stellarium.
Can I show some pictures while you switch over?
Yeah, go ahead.
So I'm going to steal your screen sharing away from you. Here's a photo from the chip of our robotic telescope in California. So it's in black and white because we were not taking color pictures using the chip that time. This is just a quick photo, but it gets some nice detail on it. And then this is a photo from the DSLR on the back of the telescope. And from the folks who took it, they mentioned that keen-eyed observers will see Arcturus in the frame. that's this thing, that's the bright thing, that's Arcturus. So we're still working on getting photos with the scope. I think they're going to try again tomorrow morning / tonight. And we'll this is in the Sky News article, I believe, about Comet Leonard, but we'll keep talking about it and post it on social media if we can.
We also have a results from the Google search. 60.5 kilometers a second is the velocity.
Yeah, and I see someone else commented about the definition of periodic comet is it's less than 200 years, period.
Okay, all right, okay.
Periodic is periodic, yeah. So, but I guess that's a good guideline.
And Lisa, who is also kindly looked up the speed, for those of you who are in Imperial, it's 158 miles. Sorry, 158,000 miles per hour.
I think that's kilometers per hour, probably. Okay, yeah.
Oh, that makes sense. Crazy.
Yeah, that's why if Earth encounters a comet, it's not necessarily a good day. That's may have been what happened in Tunguska way back when.
We have a video about this on our social media about the difference between comets and asteroids in terms of like destruction power, and comets have a much greater destruction power because they're usually often, and as is the case with Leonard, coming perpendicular to the solar system's plane, which means that there's a lower chance, but they're coming it with a much greater velocity in a different direction. Whereas asteroids are often coming along with us in the same plane as the solar system, and they're much more likely to glance as opposed to smash into us. Or that's not necessarily true. It's a possibility that they could glance instead of smashing directly into us. So comets are the ones. Be afraid, everybody.
All right. So what I thought I'd do before we get into where to see it in the sky is to help you use your favorite astronomy app or software to plot properly or accurately plot it. So if you have Sky Safari, what you can do is go into the settings, and I'll do this for Stellarium in a second here. Go to settings, look for solar system. There's a section called solar system, enter that, click that, then scroll to the very bottom and you'll see there's a button to push called Update Minor Body Orbit Data. So you want to do that, and it just takes a moment, then it reports that it's done. And now it should plot the location of the comet accurately on Sky Safari. If you're using Stellarium, what you would do is you'd go to the configuration window F2. You'd go over to the plugins tab. You'd look for the solar system editor entry in that list, hit configure, and this keeps opening more and more windows, so don't get too confused. Then you can see there are 3 tabs here: configuration file, solar system, and about. Click the middle tab. And down here it says import orbital elements in MPC format, which is Minor Planet Center. So you click that button. Another window opens up. Again, sorry for the clutter. There's 2 choices, asteroids or comets. So click on comets and then go down to select a bookmark. And you want to pick MPC's list of observable comets as your choice. Get orbital elements. Takes a moment here. Now that'll come up with a long list of them. And to save time, what you could do is just search for C 2021 A1 Leonard and put a check mark there and say add object. It shouldn't take too long. It's done. Close, close, close. And now it should plot correctly in Stellarium. If you haven't done that in a while, it could be off a little bit. So it's helpful to do that, to have that set up. Another cool tool in Stellarium you can use is to go down to the astronomical calculations window F10. And by the way, I'm using version 0.21.1, which is one before the latest. So that's fine. Go into the astronomical calculations window. Oops, I just crashed Stellarium. Let me start that up again. Yeah.
And for those of you who are watching and going, oh my God, this is so much all at once, this video is available on YouTube afterwards. And so if you, I'll send that link in the chat. And those of you who are watching on YouTube, let's hit rewind and watch it again if you need the extra steps.
Okay. Go back to 6 in the morning or so here. All right, there's Comet Leonard. So as you said, go into here. See if it'll, no, good. So you can go into the ephemeris tab. You can type in C-2021 A1 Leonard. When you start typing, you'll start seeing a number of different comets. And then the more you type, the more you'll get to Leonard. Then you can set the range of dates. So the default is a month here. So we can go from, I've got it, it'll start with the start date and time at whatever you've set Stellarium to when you open this dialog. So I had Stellarium set to tomorrow morning. It's this morning. I'll go to tomorrow. Doesn't matter. It's 6 a.m. And I'll just do a month. I'll do it for one solar day and I'll say calculate. And you can actually show a line, a dot for each day and a little date numeral beside it. So let's calculate that. And then I'll close this up. And now you've got its location every morning at 6 a.m. for the next number of mornings. So here's December 7, 8, 9, 10, 11, and so on. So remember, 12th is the closest date. But as you can see, every morning at 6 a.m., it's getting lower and lower and lower. And for Canadian observers, the end of astronomical twilight, when the sky first begins to brighten up in the morning, is around 6 a.m. So if you plan to go out and see it, try to get outside between 5 and 6. And you'll have the comet will be then in a darker sky and hopefully a little bit higher. So the earlier day you do it, the better odds you're going to have, the better luck you're going to have. So I went out this morning and Arcturus was dead easy to spot, very bright star Arcturus. That told me that the comet would be higher than my trees. So I knew it was worth getting out. And I'll just put a binoculars field on here so you can see the binoculars field. There we go, about 6 degrees. And so this morning, the comet was a bit more than a binoculars field to the lower left of Arcturus. So I found these bright stars and I couldn't see it. I was out after the beginning of twilight. So I was around 6:40 by the time I got outside. I couldn't see it. But it should get a little brighter every morning. And so here's tomorrow morning. On the 9th, you can use the triangular head of Serpens to find it. It'll be just a little bit to the upper right within the binoculars field. Then on the 10th, you could maybe use the reference of the bright star Alpha Serpentis. And then on the 11th, it's going to be getting kind of low. So you may want to go a little bit later. So by 6:30, it will be getting a little bit brighter outside, but it should be, the comet itself should be brighter and perhaps enough to overcome the twilight. So get out early, get yourself set up, find your location that has a nice unobstructed eastern horizon and take your look. So the Saturday morning, the 11th would be great. Sunday morning, I don't know, Sunday morning, it's going to be really, really low. And by the time it gets more than a few degrees above the horizon, so it's only about 5 degrees above the horizon at 6:30. And by the time it gets above less of the Earth's distorting atmosphere, the sky is going to be getting bright. So even though the 12th is the brightest day, potentially, I think I'd go out Friday, Saturday, and do your look then.
So how do you know you've actually seen the comet? Like, is there an identifying feature on the comet versus just seeing a bright object in the sky?
Yeah, so comets look a bit like globular clusters. So they're kind of small fuzzy star shapes. If the comet pans out and it gets brighter, you should see a hint of a tail. The tail will be stretching upwards away from the sun, right? Your telescope might flip that around, so you need to account for that. And what's cool about comets is that you tend to get a greenish glow, especially if you look at them in your telescope. You'll get this neat green glowing halo. It's kind of fun.
So kind of like the pictures Jenna was showing us earlier.
Yeah. Okay. But generally, visually, depending on what it does, the tail may not be all that apparent, but the fuzzy patch should be. I don't think there are no other deep sky objects you'll confuse it with, right? As long as you're following this sort of track. The M5 is over here. It would be maybe comparable in appearance, but it's not in the same neighborhood as where the comet should be.
That's fair, but you say that, but then there's an entire catalog of objects that are classified so that you don't mix them up with comets.
Well, ironically, when you do get to the 12th, and again, it'll be a bit too bright to see them, but here you've got Messier 12 and Messier 10 sitting here in Ophiuchus. So, yeah.
It's very confusing. I can see why Messier had problems.
Yeah. Go ahead.
There's a comment from Lisa saying that Lisa had it at 6:07 in the morning, and then by 6:10 it was washed out. So you really do have a very short window. And she's in Bortle 5 skies. So just a heads up if you're looking for context. So yeah.
But it should be brightening every morning, a little brighter every morning. So yeah. But yeah, this comet doesn't look like it's going to be nearly as nice as Neowise was. Maybe comparable, but I think Neowise had the edge on it. Let me finish the thought, and then we'll move on to our topic of the day. So this is Sunday morning. On Monday, next Monday, obviously the comet's going to be heading down towards the sunrise. So there's no hope of seeing it around then. But what you can do is, I'll just follow it around. You wait till the day after, so that's Tuesday morning. Then now it's in the evening sky. Okay.
Oh, but it's like right along the horizon.
But it's in the twilight. So you're not really, it never really escapes kind of look at this, 6 air masses of interference by the Earth's atmosphere by the time it's getting a little darker. And really sad to say, it's going to sit there in the evening sky for a couple of weeks. It'll pass the sun on January 3rd, but it'll just sort of march. Let me just center this up again. It's just going to kind of march southward for a couple of weeks, and then it'll kind of be heading directly away from us as it rounds the sun. So the people in the southern hemisphere, they'll have a great chance to see it during that end of December block. But for us here in Canada, it's the next few mornings,
That's all we got. Oh. There is, before we get into the overall what we're doing for 2022 plans, Jamie had a question, which is that he was surprised to hear that leaving the solar system for comets, thinking that leaving meant that it would never come back and would maybe just drift away. If it doesn't mean that, is there a term for a comet that never comes back? I mean, these things are moving very, very fast. So almost all of them do get flung out of the solar system, right?
Okay, so I actually had a little note on here about that. Let me just find my little note. So P for periodic, a period of 200 years or less. C for non-periodic, which is either extremely long return or not. If it's a hyperbolic orbit and not a parabola, is that right?
Yeah, right.
Yeah. Then it never will come back, or effectively never will. X/, if you see X/, that's uncertain. If you see D/, that's destroyed, usually when it's at perihelion. And let's see what else we have. I think there's one more. Nope, that's it.
Cool.
Yeah. So yeah, you can get a variety of them. And then it's really fun to research comets because they're all different types and families with different velocities and all kinds of different things. So a future session, we'll cover that.
Future session.
More details.
Rick says that Leonard might be on an 80,000 year return apparently. So
yeah,
not periodic, not really, not functionally periodic.
Yeah.
Have to live a long time to see it twice.
Yeah, and again, its perihelion isn't all that close, so maybe it'll survive nicely and still have lots of vim and vigor when it returns in 80,000 years. So like time capsule time. Just before we finish, so now we'll get into our 2022. Any other final questions?
I think that's it on comets. If you have more, feel free to throw them in. But for now, we are good.
Yeah, we've got some time. We can have some more discussions here at the end. So as I said, a couple of the comets that we know will be coming back are also expected to get to their maximum this year at not too bad of a brightness. So where's my notes here? So, and I'm just going to share Maybe Jenna or Samantha, you could share the link to the weekly information about bright comets, or one of those. I'm going to open the COMETS. So one place you can keep tabs on what's happening with comets is the Comet Observation Database, or COBS.SI. And generally, whatever comet is the most exciting recently will be the one that has a brightness graph. So if you click on the brightness graph, you'll see that the pale orange line is the predicted brightness based on the geometry and its distance from Earth, predicted to be brightest on December 12th. And the little green crosses are CCD observations, and the little black crosses are visual estimates. And so you can see the curve is heading up, up, up quite steeply, so that every morning should add to the brightness. And it should reach a peak, predicted peak of about magnitude 4 on the weekend. So we'll see what happens. So that's COB. And then you can also use, there's a website called arith.net that has what's bright recently, and also comets of the future. So let me just open this comets of the future one up. And he puts a graph of evening, midnight, and morning. So let's say evening sky, December, January, February. And here are the visual magnitudes down this column. So you can see that there's a comet named 2021-03 Pan-STARRS, predicted to reach magnitude 5 in May, K2 magnitude 7, and then K2 gets a little bit brighter in June and July. So you can use that to keep an eye on what's coming, and then you can use your stellarium to find those. So here's the 221-03. So it should be about at its brightest in early May, around May 7th, about 10 in the evening. I'm not saying it's brightest then, but I'm saying one of your best times to go and look for it would be around 10 in the evening. It's sitting here near the bright star Murphak in Perseus in the northwestern sky. So you can look for that one. Put that on your calendar. And then the K2 Pan-STARRS is going to be in Ophiuchus, sort of not far from where Leonard is going to pass through. And that's should be really good around July 6th in late evening. So you can check out that one as well. Yeah, this yellow path, this is the leftovers of the Leonard. So let me just get rid of that. Clean that off. There we go. So those are two other comets that you can kind of be on the lookout for news about, not to mention whatever might be discovered. So you don't know. All right. Let's talk about some other things. Some of the fun that the planets will get up to. So first of all, people like to look at Mercury. So Mercury is going to be visible several times, during the year. And the best elongation, one of the best elongations will be January 7th. So where's my January 7th Mercury here? That'll be this one. So in the post-sunset sky on January 7th, you can look for Mercury kind of grouped together with Saturn. So that's kind of a cool thing to look out for, about a binocular's width apart. A really good one happens in April for Mercury. And let me just get rid of my horizon a bit here for us. Landscape 0. So that on that date, Mercury's going to actually sit very close to the Pleiades. It'll be low, but if you get at it a little bit earlier before, it sets, binoculars, you should still be able to pick up some of the Pleiades stars with Mercury, maybe around 9:30 in the evening. So that's basically for several evenings. There'll be binoculars close, and the moon will be there too.
I'm going to interrupt for a second because Samantha and I have been sending links in the background, and I forgot to say this. Get out your date books. If you use date books, get out your date book. If you use your phone, get out your phone. If you use Google, get out Google to write this stuff down. It's going to be on YouTube later, but it's fun. I don't know about you, but I have like a little spot in my journal where I write everything that's coming up for the year. And I always write down all of the like astronomical events in there. So
yeah,
we get to do that.
So that'll be that's a cool photo op. May 2nd, the Pleiades, Mercury, and the young crescent moon in the western sky after sunset. So you need an unobstructed horizon, but yeah, future photo ops. And the last one for Mercury in the evening sky. Oh, this is a pre-dawn one. So in the pre-dawn of October 8th, Mercury will be at sort of its peak visibility around 6:30 in the morning. Not really with anything else, but hanging out below Leo. There's the stars of Leo above it in the morning sky. So those are your best Mercury opportunities. The reason that I'm emphasizing this a little bit is I got some really bad news for everybody. And so let's cover the bad news. So we've had this really great season of Venus, Saturn, and Jupiter nicely gracing the western sky. And over the next couple of weeks, we're going to lose Venus first. Then we're going to lose Saturn. And by the time we get to around, let's see, mid-January, Jupiter is going to be in the twilight glow and not really a great telescope target. And then we're going to not have any planets in the evening sky, no bright planets, until, let's see, August.
What?
Yeah.
That's so long.
Yeah. So for folks that are getting telescope for Christmas and things like that, you're going to have the moon, but you want to grab, a nice book about Messier objects or something like that, because you're not going to have any planets to see in the evening. But the good news is that there's a fantastic planet dance that's going to happen in the pre-dawn if you're willing to get up early. So yeah, so what happens is that I'll just advance the clock here a little bit. All right. So by the time we get to, here we go. So in August, we'll have Jupiter and Saturn reappearing in the evening sky, about late evening after 10 p.m. And then we won't get Mars joining the party until the end of October. And then we won't get, I don't think we get Venus until, is it November? We might get Venus, or even December. But yeah, so most of the year is going to be wiped out for planets. So you want to get onto your double stars and your DSOs and things like that. Right. So what do we got here?
Too bad.
Sorry,
Gotta
everyone.
find another go-to target to show to amaze people. That's easy to find.
Yeah. So this happens sometimes for those of us that do outreach, especially with schools and things like that contact us and want help with things. To have to say to them, well, you'll have to pick a night where the moon's up. Otherwise, there's nothing in the way of planets. And most schools are not in dark sky sites. So if you don't have the planets on the moon, you're really limited in what else you can show them. Venus's best appearance for 2022. So we've had it all summer, all year, most of this year in the evening. So Venus is going to join the morning sky in 2022, and its best is going to be around the end of March. So that's going to be great. What's cool is that when that happens, there's part of this dance I was mentioning a minute ago. So you've got Venus, Mars, and Saturn, and the asteroid Vesta, all in the same sort of patch of sky when Venus is at its best.
Well, that's nice. At least you just need to wake up early.
Yeah. So in terms of seeing the planets at their very best, Venus will be at its best here at the end of March. So we've got that one. We've got, let's see, Jupiter. So Jupiter is going to be at opposition when it's biggest and brightest in the sky, September 26th. And this little symbol ASP, it stands for anti-solar point. So this is the point in the sky opposite the sun. That's what opposition means, that the planet is opposite the sun in the sky, which means that Earth's orbit is reaching towards that orbit, that planet's orbit, and we're at a minimum separation, the two planets, Earth and the planet. So that'll be September 26th for Jupiter. Saturn is a little earlier. Saturn is August 14th, opposition date. And again, don't freak out if it's cloudy that night. within a few nights, it looks almost as good. And those are obviously opposition nights are the best nights to see the planets. Moons at their brightest as well, so don't forget the moons. Uranus is going to be at its peak November 9th, but the full moon will be up, so you'll want to go a few nights later. And then, let's see, Neptune is September 16th. So Neptune and Jupiter will be kind of hanging out near one another all year long. So those are your prime nights for seeing those planets. Oh, and not to forget Mars. What we're going to do a separate insider's guide on Mars, because Mars is going to do a whole bunch of cool things leading up to its opposition night on December 7th, right beside the full moon. And I don't know if I have it on here. Let me see if I get this to work. Ding, 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 ding. Guess what? The moon is going to occult Mars for Canadian observers on the opposition night. Yeah.
That's just a coincidence, but like, wow, what a coincidence.
Yeah.
Oh,
I think the moon was full at Mars's opposition in 2020. I don't remember, but I seem to recall the moon was full then too. Yeah, so around 10:28 p.m. in Toronto time, and it'll vary. You know, everyone can use their stellarium for their city to figure this out. Some people might miss it. It might be a grazing pass, but for us, it's about 10:30 p.m. till 11:17 or so.
I would like to, really quickly highlight, as the lazy astronomer in the room, how great this event is. It's at a reasonable time. It's visible to Canadians. This is like, and it's something that doesn't happen that often. This is a gold mine when it comes to the things that I'm willing to do for astronomy.
And you know what?
Too, that you can see easily, right? Like they're no deep sky objects. You can see them in the city.
It's a year to the date from today.
Yeah.
Oh my gosh. Yeah.
Wow. Okay. The coincidences abound. And also, Jamie pointed out that he's got to try and observe it just so that he can say he's seen a lunar Mars set, which it very much is. That's what it is.
And Mars won't look as big as the moon in the telescope, which is the other meme that people talk about.
Watch out. Yeah. Watch out on the internet for those, I'm not going to say they're news organizations, but some news organizations do it, where they'll like post a photo of Mars next to the moon. They're not the same size.
Yeah. That is amazing. And that's going to be John Reed's birthday too, by the way.
No way. Oh, I should message his birthday today then.
I think so. So yeah. And Mars will be at its opposition. So it'll be close to its largest disk size. So that's a major highlight for the year. Hopefully everybody's ready for that. Pleiades nearby.
Will this provide an interesting photo op at all? Will that be something people are interested in?
Well, the moon, the bright moon will make it tough.
Yeah.
The bright moon will make it tough. But I have faith that, we've got talented RASC members that'll definitely get that.
This is how, just plugging ourselves for a minute. Joining RASC, watching these shows, getting your observer's handbook, and reading Chris's blog is how you get ahead of the social media blitz. It's how you get the photos that you're not looking at them the next day going, oh man. Unless of course you get clouds. And then in that case, you're still looking at them the next day going, oh man.
All right. So what I'm going to do is I'm going to take us back to now, and I'm just going to advance the date here a little bit. So we've got Mars visible in the morning sky nowadays, and it's actually getting better and better as it climbs farther from the sun every morning. On the 1st of January, so to ring in the new year, let's see, here we go. So I don't know if you can see this. We've got Mars's rival, Antares, in the same binocular field, and the old crescent moon in the same field of view. So again, you want a nice low horizon to the southeast, and just appreciate that. Really cool for your New Year's morning look. All right, so what else we got here? So let's just carry on here a little bit more. Yeah, that was 31st, but the first is basically the same. So the 31st will have the moon the moon will be lower. The moon will still be there. Let's see, where's the moon? So yeah, the moon is there both mornings, but it'll be better on the 31st. So, and technically 2020. All right, so then you can see that we've got Mars in the morning sky. And as we kind of journey further into the year, here comes Venus. So Venus will join the morning sky in January. They're going to get relatively close to each other. By the time we get to February, so you've got February 2nd is when Mercury is closest to Venus and Mars. So let's just run this back a couple days. So we've got this cool Mercury, Venus, and Mars, a pulse or grouping. We'll just carry on a little bit more. And then before long, we'll get Jupiter joining the show. So we'll just advance here a little bit more. And by the way, on about March 14th, the Venus will be at its closest to Mars. So they'll be, you know, binocular field apart. I carry on a little bit here. So March 23rd, I've got, here we go, March 23rd. So now we've got, let's get this lower here. So that was that grouping I mentioned before. We've got Mars, Venus, Saturn, and there should be the moon on one of these mornings as well. Should be there as well, but yeah. So that's a cool one to look for. Then by the time we get into April, we get Venus, Saturn, Moon, and Mars on March 28th. We've got Venus and Saturn getting nice and cozy with one another. And we'll carry on a little bit here more. And just drop this a little bit lower. I think Mars passed really close to Saturn.
Oh, wow.
Yeah. So that is, I think, telescope close. Let's just measure this off.
For those of you who remember last year at this, well, around this time, we had Jupiter and Saturn pass telescope close.
Yeah. So that's 24 arc minutes, and the moon is 30. So it's less than the diameter of the full moon. And this would be easily the field of view of a telescope, backyard telescope. So you can catch the rings of Saturn and Mars in the same view in your telescope for a couple of mornings. So basically 4th, 5th, 6th or so, they'll be close enough to see together. Well, let's see what else have we got here coming up. Yeah, so Mars is going to do this neat dance with a whole bunch of planets passing close to them. Okay, here comes Jupiter. So Jupiter and Venus are going to have a kiss around April 30th, May 1st. Now, Venus is so bright, it might spoil the show a little bit in your eyepiece to see Jupiter, but you can always just hide Venus outside the edge of the field of view and then bring it back and sort of play with it a little bit. But they're telescope close as well, so April 30th around that time. Yeah, and there's a bunch of times where the old crescent moon will be amongst the planets as well, all through the spring, so that's kind of neat. May 29th, yeah. We're not done because we've also got Mars gonna kiss Jupiter. So now it takes its turn with Jupiter around the end of May, so May 29th. Again, telescope close.
Mars
and this
just
will be
wants to
nice.
get close to everything.
This will be nice. So Mars will not overwhelm Jupiter or vice versa. They should both really look really neat in the eyepiece.
There was a note from Robert, and I haven't mentioned it yet because I was waiting for you to get to this point. After this point, it seems like Mercury, Venus, Mars, Jupiter, and Saturn will all be in a line from east to west that is the same line that, oh wait, no, maybe not Mercury. That is the same line as they appear, like they're in order as they are as the distance from the sun. So it goes Venus, Mercury,
Oh, yeah.
Venus,
That can
Mars,
happen.
Jupiter, Saturn. Yeah, which is kind of nice.
Yeah. Although it's a trick of the eye because Mars will be maybe closer to the sun, beside the sun. Jupiter is beyond the sun.
Yeah, they're not lined up.
They're not truly lined up, but they're just from the point of view from that point of view. Yeah. I was just going to look up Mercury. Yeah, Mercury around the end of April. So Here we go. So yeah, at the end of April, we should have Mercury. Here we go. Let me bring this up. Or is Mercury in the evening? Maybe Mercury's in the evening. Yeah, never mind. Mercury's in the evening. But yeah, you can see there, you've got lots of instances where the planets are going to be aligned and grouped together in the pre-dawn sky. All right, so let's just finish this up where we want to go from here. After the end of May, kind of all the cool, conjunctions and oppulses end for a while. And then we get to Mercury with Venus at the end of the year. So let me just jump into December. And let's see, when is this going to be visible? So this will be in the evening sky around December 24th. So Christmas Eve we should have Mercury, Mercury, Venus, and the old crescent moon. That could be a neat photo op. They're a little bit low on the low side. And then on the 28th, 29th, then Mercury and Venus will be not quite telescope close, maybe. I don't think not quite, but again, Venus tends to really overwhelm the other planets. So you'd have a hard time seeing Mercury easily beside Venus, I think, in the telescope, but just hide Venus out of the view. So those aren't bad. Those are some cool events to look for if you're willing to get up. I'm not. Some of us aren't pre-dawn astronomers.
It's not going to be my year.
No, this is the year of pre-dawn astronomers.
All right, let's talk a little bit about the moon. So Jen and I have talked about lunar X's in the past, and I'm sad to announce that, let me just do this one. There's only one lunar X in 2022.
What?
Yeah, only one that's visible in the evening sky in a dark sky. Yeah. So that's on the 9th of January in the evening. They'll have the lunar X and V opportunity, and it'll be at a relatively comfortable height above the horizon. So this is the peak is around 11 p.m., but the X should start forming, at least an hour before that, and last at least an hour after that. So say 10 p.m. till midnight Eastern time, or 7 p.m. to 10 p.m. Pacific time, depending on your time zone. So and that's kind of it. That's your only lunar X for the year.
Well, I guess at least you can see it start to finish, which is kind of cool.
Yeah. Then we've got on January 17th. So where's my January 17th? Bring this up. This is the smallest mini moon of the year. So because the moon looms larger and smaller, depending on whether it's full while it's at perigee or apogee. So this is your apogee full moon. So your smallest, the moon will look at smallest for the year. So if I bring that, I'm just going to change my ring here to a moon-sized ring. So let's do 50, 0. So you can see that the purple circle is just the size, just a little bit bigger than the moon. So the moon is normally exactly the size of the purple ring, 30 arc minutes. But on this date, it's going to be 29.9, so a little bit smaller, slightly smaller. So that's your mini moon on January 17th. But then the supermoons, and again, astronomers, we have a love-hate relationship with the word supermoon. But anyway, it gets people outside, which is cool. So the supermoon is going to be 2 of them. So on June 13th, we have a 33.45 arc second diameter moon. Let me just rise this up a little bit. So you can see the same purple ring, how much bigger it is than the mini moon, Jane.
So looking at it in isolation, that does feel like it is a big difference, just looking at the moon and the screen. But it's not, it's maybe noticeable, maybe.
Mm-hmm.
Well, to a casual glance, it probably wouldn't be noticeable. But if you have to reference it to something. Most of us use our little pinky finger, which is larger than you need. but maybe you could use the, the width of your nail bed or something like that to measure it a little more accurately and get a difference. Obviously, if you photograph it, if you made a project to photograph the full moons through the year, you could then put them side by side and you could see the sizes vary.
As long as you shot them at the same focal length every single time.
Yeah.
Mhm.
Yeah,
Otherwise,
same
it's
lens.
just photoshopping.
That's right.
Yeah.
Well, you can do it with stellarium too. So this is the June one. And then July is the actual largest full moon of the year. So and this one is just a few percent bigger than the previous one. So not that much, but not much bigger. So I don't know if everyone's aware, but because the moon's cycle of phases, its synodic period is 29.5 days, but its orbital period is 27 and change days. That's the sidereal period. Those two periods are different by about 2 days. And what happens is that every number of months, they synchronize for a short period of time. So you'll always get supermoons in clusters of 2 or 3 while the 2 cycles are synchronized. So they'll come into sync and then they'll drift out of sync. So you'll have a few 2 or 3 supermoons and then they're gone until the next round. So we only get 2. I think we had 3 in 2021. Okay, a couple more cool things. So October 24th, we already mentioned the December 7th occultation of Mars. So October 24th, we have the old crescent moon occulting Mercury in daylight. All right. So again, parental discretion obviously is warranted here. You've got to be really careful. You've got the sun in the sky,
Really
not
close to
that
the
far
sun.
away. Yeah. So if you've got your telescope uncapped, you'll want to have, take great efforts not to allow any sunlight to enter the objective lens or the primary mirror. But it's a sort of a curiosity thing. I don't think it's going to be easily observable, but around 10:15 a.m. on October 24th, the moon will occult Mercury. And Mercury's got a reasonable -1 magnitude, so it's relatively bright. And then about an hour and a bit more than an hour later, Mercury will reappear. So
I think this is very cool. I will say I have tried to just image a moon that was nearly that thin once. And it took me an hour of searching in binoculars to find it.
You'll need a go-to probably. Yeah. You'll need a go-to to find them. Yeah. What we can do is here, just to give people an opportunity, is to see if how it would be different in Vancouver. So let's see.
You could watch it unoccult in Vancouver, but it looks like the actual occultation before sunrise. Oh, maybe not.
No, it's okay. But it might be, it'd be somewhat safer than it would be in the Eastern time zone just because the sun is out of sight there. Yeah. So it'll be that you're not gonna be able to see that, but the egress you'll be able to catch if you want to.
Egress, not unoccult. That's the word.
Come on, Jenna. You know that.
Sorry.
All right. How are we doing? We're okay. So let's talk about, we've got enough time, I think, to cover the eclipses for the year. So in 2022, we've got two partial solar eclipses only, but we get 2 total lunar eclipses. So the folks that stayed up late to see the partial lunar eclipse a few weeks ago can do what I did and not set the alarm and wait for the May total lunar eclipse. So let's see. Here's the moon. So let me just put this out of the way so everybody can see. 15th of May. And it's actually 15th of May. In late evening, so around, here we go. What I have it here at, totality should begin at, here we go, around 10:30 p.m. And the moon will be Nice and high in the sky, no problems with that. Visible all across Canada, all of North America, all of Central America, all of South America will see the entire eclipse. And people in Europe and Africa will see later stages. So we get to see the entire eclipse, which is great. So this will run for a total of, let's see, 1 hour, 25 minutes of totality. So it's over at around 1:45, 1:50 in the morning. So that's great. Eclipses, a lunar and solar eclipses always come in pairs. So this is actually the second of the pair. The previous 2 weeks is April 30th. That's the partial solar eclipse. So where's my partial solar eclipse? Here we go. So the partial solar eclipse is visible from central Bolivia southward to the northern reaches of Antarctica. So it's going to happen on the morning of April 30th, or sorry, the evening of April 30th. And I think at greatest eclipse, it's only 54% of the sun will be covered. That's the maximum. So this is the eclipse is visualized from Punta Arenas, Chile. So it's that one. That'll be broadcast on the web, so people can watch that one if they're not able to get down there. And then later in the year, and by the way, you, Jenna or Samantha, you can post those eclipse-wise links on the chat if you want to with the diagrams. Let me just bring up these are cool diagrams. Let's see if I can open this link up.
Question about eclipses. Can you have a lunar eclipse without a solar eclipse, or are they always in pairs?
I can answer that one. You can have a lunar eclipse without a solar eclipse, but you can't have a solar eclipse without a lunar eclipse.
Cool.
And the reason is that the eclipses occur when the near the point where the sun and the moon are at the point where the ecliptic and the moon's orbit intersect. And you need more than 2 weeks to escape the circumstances. So that's why within that sort of 2-week block on either side, the moon is still near enough the ecliptic to cause the lunar or solar eclipse. But yeah, thanks, Jenna. Okay. So Fred Espenak publishes details on eclipses all the time at ECLIPSES. This is the information for the lunar eclipse of May 16th. And if you actually click down on the eclipse figure, then you get what the moon is doing. So it's passing through the umbra of Earth for a total of 1 hour, 24 minutes. And then in the gray ring here is when you see the partial phase, when the moon has a part of a bite out of it. And then the visibility of the eclipse, the light colored areas get to see all of the eclipse, the dark see none of it, and then the grays are part of the eclipse. So these are neat diagrams that you can use. All right, so those are the first two in the first part of the year. Then on October 25th, we get, oops, not that one, this one. October 25th, we get a partial solar eclipse visible from all of Europe except southern Spain, northeastern Africa, the Middle East, and Western Asia. And this is a deep partial eclipse. Again, I think it's about half the sun will be covered. And this view here is shown from Svalbard, the islands east of Iceland, north of Europe. And you can see that the sun is just rising in eclipse, and then the moon is moving off. So again, just partial eclipse. And then 2 weeks later, on November 5th, where's my November 5th? November 8th, I mean.
Just because of the way the moon sits in that first one, the one that you had in Svalbard, it almost looks like the moon's sitting on the horizon. Like it's like a circular building blocking the sun.
Yeah. It'll make for some neat photos with the scenery. Okay, so this is so for the previous eclipse, I think the Western Canada was going to miss that one, the total all of the eclipse, but for this one it's reversed. So the Eastern Canada misses this one, parts of this one. So here, I'll just bring up the picture again. Here we go. So instead of the moon scooting across the southern half of the Earth's shadow, it's going to scoot across the northern half of the Earth's shadow. So in this one, you can see here that Western Canada will see all of the eclipse in totality. Eastern Canada will only see the first stages of the eclipse. So that's why in this scenario here, you'll see if I advance the time that the moon will set in Toronto, but it'll stay above the horizon ending. So this one starts in the only disadvantage is that this is a pre-dawn eclipse. So this one's going to start at about 4 a.m., a little after 4 a.m. And then it'll end, as I said, in the early morning. So I'm going to pause there. Any questions on any of that so far?
So far, no questions, but Douglas had a comment and I wanted to address it because we have a couple years of interesting stuff coming up. Douglas went down with his son to Wyoming in 2017 to see the total solar eclipse that happened then. This coming year has 2 nice total lunar eclipses, but no total solar eclipse. But in 2023, there's going to be an annular eclipse, which is not a total solar eclipse. That's technically speaking, a partial eclipse, but the moon blocks, like you can see the moon and the disk of the sun. It just leaves like a little ring of light around the sun because the moon is smaller in appearance than the sun.
Yeah. So if you go, go to ECLIPSE-wise, I'll just head this up while you're talking.
Okay. And then in 2024, this is the big year, which we're already planning for. And many people already are. That is going to be a total solar eclipse that comes through Canada. Woohoo! It's going to be just south of Toronto. Toronto's going to have a 99% blocked view, or like a 99% eclipse of the sun. Hamilton is going to have 100%. Newfoundland is going to have 100%. Parts of Quebec and New Brunswick are going to have 100%. And then, of course, large parts of the United States will have total solar eclipse as well. We saw this in 2017, a similar setup, less so in Canada, more so in the States, and it wreaked havoc. It always does on tourism industries in the past. Good havoc, like it's always really busy, but the kind of havoc where like you should start thinking about planning your trips now and booking hotels, and also letting hotels know after you've booked that they should increase their rates. And also making them aware of the situation, because I have heard of scenarios where if you book a hotel for years in advance to go see a total solar eclipse and you call them back the year of the eclipse, they will say they have lost your reservation because they have increased the rates, realizing that they can, and gotten rid of the reservations prior. So things to consider for 2023 and 2024, but for 2022, it's going to be lunar eclipses.
So yeah, so if you live, I don't know if that's near Dallas or Central Texas, they get both eclipses.
Oh,
so the red stripe is the annular eclipse path, and the blue stripe is the total eclipse path. So it runs up from Mexico right through Dallas, Texas, the city of Dallas, Buffalo and Niagara Falls, and then out to Newfoundland. Yeah, fantastic.
I'll also make note of the fact that there was a total solar eclipse in Antarctica a couple days ago. And you should see, there were a group of astronomers that did go. I saw that the editor-in-chief of Astronomy today went. So you'll see some photos of that around on the internet too, if you didn't go yourself, which I assume most people did not.
Yeah. Okay. So the last thing I was going to mention was the outlook for meteor showers this year. And we've got good news and we've got bad news. So let's bring up the meteor showers on here.
Keep on giving us bad news. We just want all the good news, Chris.
Well, I like to balance it out, right? I like to offer some consolation. So, all right.
True.
All right. So in January 3-4, we get the Quadrantids meteor shower. So let's just bring this up to January 3-4. And we'll go into the morning sky. So the Quadrantids meteor shower They're named after a defunct constellation called the Mural Quadrans, or a quadrans is a quarter son of a set square that used to use in navigation and cartography. And it sits up here between Bootes and Draco, near the handle of the Big Dipper. So that's where the radiant is. But of course, you don't watch the radiant during the meteor shower, because the meteors here will be heading straight towards you, and they won't have very long trails. So you want to look elsewhere in the sky, but that's where they should originate from. So in the pre-dawn, say evening of January 3rd to the pre-dawn of January 4th, we get the Quadrantids meteor shower. And what's great is that that night, there'll be a young crescent moon that'll get out of the way after 5 p.m., leaving the whole sky moonless. So the whole night moonless. So that'll be a great opportunity. You can get between 60 and 200 quadrantid meteors near the peak night. And so we're calling this a woohoo, a yay, hooray meteor shower.
What type of skies would you be able to see it in?
Let's see if I have the facts on the quadrantids here. There's a great web page that I use called AMS Meteors, American Meteor Society, and they have little summaries. Let's see, I'll bring up the meteor shower summary. So quadrantids. So let's see. These ones usually lack persistent trains behind them, but they're often frequently bright fireballs, which means they're good for urban as well. Not very well seen from the southern hemisphere, so because they're very northerly, so it's good for us. Is that what you're driving at? I think.
Yeah, I wanted to see if I could see it where I live, or I have to go somewhere.
Yeah, because the fireballs will be a subset of the main shower, but chances are if you park yourself outside on the driveway or something, or the backyard, you could catch one. And actually, the fireballs tend to be more in the dusk and dawn periods, because the meteors are skimming across the Earth's atmosphere, and that's cool. Okay, so that's that one. And then we've got the next woohoo shower is the evening of May 5th to 6th. So let's go to May 5th to 6th. And we've got the Eta Aquarids meteor shower. So here's the constellation of Aquarius. And this one is about 60 meteors per hour at the peak. And on that night, we've got the crescent moon will set after midnight. So that leaves the rest of the night moonless. And the Eta Aquarids shower, let's see, is better from the southern hemisphere. Maybe only 10 or 30 meteors per hour in the northern hemisphere, so may not get as many. High percentage of them have persistent trains, but not very many fireballs. So Samantha, you're not going to be as good for that one. And then the boohoo is the Perseids, everyone's favorite Perseid meteor shower, which is around the 12th, 13th of August. So where's the Perseids here? So here we go.
I'm sure you'll see lots of, again, this is one of the news's favorite topics to advertise the Perseids meteor shower, and you'll see lots of hype. So what Chris is saying is don't get too hyped.
Yeah, because of this.
Stupid moon.
The moon will be full on the peak of the Perseid meteor shower, and it's going to be in the night sky all night long. Yeah, basically. So by the time the sky is lightening and the shower is ending, the moon is setting. So yeah, we had a couple of good years, 2020 and 2021 were pretty good for Perseids, but we're going to have to go through a moonful 2022. But since we're into good news, let's look at 2023. What do we got? There's the moon. I don't see any moon.
Ooh. Are the Perseids? I've heard they were getting less and less every year. Is that true?
It may be true. I haven't researched that. Let's see, what's the Perseids say here?
There was a surprise outburst last year. I remember that. There's like a very sudden bunch of meteors.
Yeah. So no, not to fear. 2023 will be
Okay.
back to prime meteors. Perseid
You had
meteors.
me worried there for a second.
Yeah.
I always go out and see those.
And one more. Let's see. We have the Orionid shower, which is a medium shower. That's in October of 2022. It has an old moon. So let me get this to October 21st, around 2022. So the Orionid shower, and it'll have, I think there's some moon in the sky. There's an old moon in the sky. So the moon won't bother us very much, but it's not a very prolific shower. So, but it's something you can keep an eye out for. And then the other good shower of the year is the Geminids, which we're just coming up on now, but in 2022. So at the peak is a December 13th, 14th. So that's next week. So let's go December 14th, 2022. And again, here's the radiant for the Geminids near Castor and Pollux. But we've got the 68% illuminated moon in the sky. So that's a boohoo. So I've got 2 woohoos and 2 boohoos for 2022.
Oh, well, that's not bad.
Yeah. And that's all I was going to talk about for now. I just want to mention that the James Webb Space Telescope should see first light in 2022. That's celebration. Fingers crossed, everything goes great for that. And also the Vera Rubin telescope, which used to be called the LSST. That's the big telescope. It should see first light at the end of the year, maybe 2023. I'm not sure. Go ahead, Jen.
I was going to say that Eric Briggs, who is not only a RASC board member, but also a very accomplished observer. So take this with a grain of salt. Eric Briggs is going to be trying to observe the James Webb Space Telescope as it heads out to where it's going. I suspect it won't be visible from where it is going. However, we don't know if unless we try. So he's going to keep observing as it goes. And it's going to get harder and harder to observe as it continues on. He's going to try to keep an eye on it and see how it goes. And then he described it as as a piece of jiffy pop the size of a tennis court. It really is. It's like this little tube-shaped thing, and then it goes poof, and it opens way up. So
that's great.
With it being so big and with those big bright solar shields, it may be visible. Who knows?
That's cool. Right. I'm going to stop my share.
Douglas says to watch for the Orion capsule around the moon in February of 2022. Apparently it's the first flight of the Orion moon rocket, and SLS, which I'm not entirely sure what SLS stands for. I'm a bad astronomer.
Fantastic. Yeah. Let me just see if I've got a couple minutes left. I'm just going to see if I've got some highlights for the rest of this month to keep an eye out for in my notes. So let's see. So we've got the full moon on the 19th. Venus, Jupiter, and Saturn have been together in the western sky for a while, and Venus has actually been creeping towards them as they get carried west. And so they'll be at their minimum string length on the 17th, 18th. So there'll be about 30 degrees apart, the string with Saturn in the middle. We've got full moon on the 19th, we've got the solstice, we've got the Ursids, and then Mars in the morning. Look for Mars in the morning sky near Antares at the end of the year. So yeah, those are.
Janine has a question for you, Chris, you specifically. And I'm going to read it out because it's very nice. You make presentations look so easy, but I know how much time and effort it must take to put these together with the verbal and visual clarity you've become known for. Could you please share a couple of highlights from your observing and or your teaching career with your background in both astronomy and geology in mind?
Oh, wow. Off the top of my head. Well, I have a portable planetarium, and when we're not in pandemic, there's nothing more fun than having a whole gaggle of kindergarten kids in the planetarium. And my favorite story is that with the planetarium I have, you can lift off the Earth and fly and land on the moon. And I always ask the kids to buckle up and make sure the oxygen's flowing in their suits and things like that. And so I once did a day where I had 3 separate groups of kindergarten age kids in a row, not mixing with one another. And when we landed on the moon, I said, okay, we're now on the moon now. And they all, each group, without me prompting, spontaneously stood up and started to walk like they were on the moon. It's just wired into them. That was one of the most fun things. But yeah, I mean, I don't know off the top of my head. Neowise was great. That's a great memory. Seeing Jupiter and Saturn together in a telescope last year, that was great. I just recently finished the Finest NGC program, Rask's Finest NGC program. I'm submitting that. And I've been writing about not Messier targets in Sky News, and there's some real gems in some of these other lists that are really worth looking at. So don't just look at Messier objects. There's more to see. I don't know. Thank you. I appreciate that.
Janine is right. Chris, and I'll take a few minutes, just a quick second to say that Chris really is the force behind this show. Chris does all the work in preparation. We only do like the technical stuff in the background, Samantha and I. And so Chris is like a superstar volunteer, considering this has been going on for almost 2 years now. And he keeps coming up with new ideas and still having lots to say.
I still have a list.
You still have a list. We built, like, the list gets longer and longer every time. So
yeah.
Thank you so much for all that you do, Chris.
Well, thanks everybody. You know, well, when the pandemic hit and the lockdown happened, I just thought of all those students that were sitting there at home, when parents not knowing what to do with their kids. And I thought, well, let's put on a show. So I asked Jenna if she was interested in putting on a broadcast in the afternoon, and that's what this has become.
And it's been such a great place to meet all of you. It's been really lovely.
Yeah, it's wonderful. Thank you everybody for tuning in faithfully like this. It's been great. And so we're going to take a break.
Yeah, we're taking a break. I guess we should say that. Yeah, we're taking a break from now until mid-January or so. And so we will set you all free for the holidays to enjoy them. And then we will be back again January 18th.
Yeah.
And then we're going to, do we know what we're talking about on January 18th yet? We talked about it.
I can't remember whether we were planning, we could cover Mars, we could cover,
We'll post it on rask.ca. Keep an eye out.
And we take requests.
We do.
Excellent.
All right. Thanks, everybody.
Thanks, everybody. Have a good holidays. Everybody stay safe, stay well, stay happy.
Stay warm, too.
Keep looking up. Clear skies, whatever you can do to make the skies clear, the mornings clear over the next few days. Please do it. And let us know if you see the comet.
Yes, send us your photos on social media.